Ever wondered how AI transforms a simple text prompt like a white cat playing basketball on a court into a vivid image? Most models today generate images all at once, but they often struggle with details, like ensuring the cat's paws look natural or the court's lines align. The problem? Traditional methods perform a single search for reference images before generating the entire picture. Imagine a painter who glances at a few reference photos once, then tries to paint the whole scene from memory. Mistakes happen. Maybe the basketball hoop ends up in the wrong place, or the cat's fur looks unrealistic. But what if the AI could continuously refine its work as it goes? That's the breakthrough behind AR-RAG, Autoregressive Retrieval Augmentation. Think of it as a painter who constantly checks their sketchpad, adjusting details in real time. Here's how it works. Instead of a one-time search, AR-RAG breaks the image into tiny patches, like puzzle pieces. As it generates each patch, it queries a database of real-world images to find the most relevant visual clues. For example, when drawing the cat's paw, it might pull a patch of a real cat's paw from the database. This database isn't just random images. Each patch is stored with its neighbors, the patches around it. When generating a new patch, AR-RAG checks these neighbors to find the best match, like a librarian helping you find the right book based on what you've already picked out. Now, how does this improve results? 2 key techniques. 1. DAiD, Distribution-Augmentation and Decoding. Think of this as the AI saying, I predicted this patch, but here's a better one from the database. It blends its own guess with a retrieved patch, like mixing paints to get the perfect shade. 2. FAiD, Feature-Augmentation and Decoding. This one refines the retrieved patches, making sure they fit the scene. It's like a sculptor tweaking a clay model to match the overall design. And the results? AR-RAG outperforms existing models on major tests. On a dataset called Midjourney 30K, it achieved a 6.67 FAiD score, super low, meaning images are super realistic. On another test, it scored 0.78 overall, setting a new record. This isn't just about better images. It's about AI that adapts, learns from its own mistakes, and creates more coherent, realistic visuals. Imagine a future where AI doesn't just follow instructions, it understands them piece by piece. Next time you see an AI-generated image, think, how did it know to make the cat's fur just right? Maybe it's not magic, it's AR-RAG, working its patchwork magic behind the scenes. But there's another breakthrough in this space, FAiD, Feature-Aware Image Diffusion. Think of it as an AI's super smart assistant, guiding it step by step to build a picture. Instead of just guessing, FAiD hunts through a massive library of existing images, pulling out tiny clues called patches. These patches are like puzzle pieces that help the AI make smarter choices, ensuring the final image fits the description perfectly. Here's how it works. When the AI starts drawing, it doesn't just rely on its own knowledge. It searches for patches that match the scene it's trying to create, like a writer checking a thesaurus for the perfect word. But how does it know which patches to use? That's where retrieval distributions come in. Imagine you're writing a story and want every sentence to fit the theme. The AI does something similar. It calculates how likely each patch is to belong in a specific part of the image. Then it blends these clues with its own predictions using a special formula. The magic knob here is lambda, which acts like a volume slider, adjusting how much weight the patches have compared to the AI's own ideas. Now here's where it gets really clever. During training, the AI doesn't just follow text prompts. It practices denoising images, like editing a blurry photo to reveal sharp details. But FAiD adds a twist. At every step, it pulls in relevant patches and smooths the image using multi-scale filters. Think of it as painting with different brush sizes, tiny strokes for fine details, big sweeps for overall flow. This dual approach lets the AI balance creativity with precision, avoiding the hallucinations that trip up less careful systems. The results? Pure magic. When tested on tough benchmarks like Gen Eval and DPG-Bench, FAiD outperformed traditional methods. Need a cat with a specific fur pattern? It's closer to the description. Want a sunset with exact colors? The AI nails it. And metrics like FAiD, which measures how real the images look, show massive improvements. It's like swapping a pixelated screenshot for a high-res photo. The difference is stunning. Of course, FAiD isn't perfect yet. It works best with simpler image formats and relies on a database that's smaller than industry giants. That means rare scenes or hypercomplex details might still trip it up. But researchers are already scaling up the database and exploring 3D applications. This is just the beginning of a smarter, more context-aware AI, one that learns from examples, not just data. FAiD isn't just about better images. It's about building AI that understands why a scene matters. By blending retrieval with generation, we're creating machines that don't just mimic art, they grasp the logic behind it. And as always, the next big leap is just a few lines of code away. Thanks for watching. If you want more deep dives into AI's wild world, hit subscribe. And hey, what's your favorite AI-generated image? Let me know in the comments.